Hello and welcome to the next video for Unit 4, and this is Section 4, and this is the quadratic formula. This is one of my favorite formulas, okay? So what we want to do is to find real and complex solutions of quadratic equations using the quadratic formula. Use the discriminant to determine the number of types of roots of a quadratic equation. So before I do anything, I want to do this up here, okay? Let's say we just have the generic quadratic equation. Ax squared plus bx plus c, and that's equal to 0. Okay, so what I want to do is I want to solve this just by doing by completing the square. Okay, so the first thing I'd want to do, and you guys don't need to write this down, I just want you to watch for a second. I'm going to divide everything by a, okay? And so we end up getting this. We end up getting x squared plus b over a x plus c over a, and that's equal to 0, okay? And so if I were to solve this for x and use completing the square, then what I would do is I would subtract both sides by c over a, so minus c over a, okay? So then I get x squared plus b over a x plus blank is equal to negative c over a plus blank. Okay, so now what I'd want to do is I'd want to complete the square on this and make this into a perfect square trinomial. So what I do is I take my, my middle term here, which is b over a. So I'm going to do b over a. I'm going to multiply that by a half and then square it. So I end up getting this. I end up getting b over 2a, this quantity squared, okay? And then if I were to actually square that, then that's going to give me b squared over 4a squared. Okay, so I just took b squared, 2 squared, and a squared and got this. So this is the number that's going to go here. Okay, this is going to become b squared over 4a squared. All right, so then you get same thing over here. I'm going to get b squared over 4a squared. Now what I want to do is I want to combine these two numbers. All right, and so if I were to do that, let me kind of do that up here. Let me do negative c over a plus b squared over 4a squared. All right. So what I would have to do in order to get a common denominator here, I'd have to multiply this by 4a over 4a. Okay, so then this gave me minus 4ac all over 4a squared plus b squared over 4a squared. So if I combine these as one number, okay, I'm going to do it like this. I'm going to do b squared minus 4ac all over 4a squared, okay? Now, what I have over here is I have x squared plus b over a times x plus b squared over 4a squared. This is a perfect square, okay? And what I need to do in order to factor that is look at what I took and divided by 2. All right, so what I'm going to get here is I'm going to get x plus b over 2a, this whole thing squared. Now what I'm going to do is I'm going to take the square root of both sides, take the square root of everything, and I'm going to end up getting x plus b over 2a. And this is going to equal plus or minus, okay, the square root of b squared minus 4ac over the square root of 4a squared. Now the beautiful part about this is that I can actually take the square root of this part. All right, so I get x plus b over 2a, and that's equal to plus or minus the square root of b squared minus 4ac all over, square root of 4 is going to give me 2, square root of a squared is a. Okay, so now what I'm going to do is I'm going to subtract b over 2a from both sides. All right, so I get that x is equal to opposite b over 2a plus or minus the square root of b squared minus 4ac, and then this is over 2a. Because I have a common denominator, when I solve this for x, I end up getting opposite b plus or minus the square root of b squared minus 4ac all over 2a. And this is what x is equal to. Okay, now remember what this is. This, folks, is the quadratic formula. Okay, and that's how you get it. You get it by completing the square. So let's say you don't like factoring. Let's say you don't like to do completing the square. If you know this formula, okay, you can always solve a quadratic if you know how to do this. And remember that this is the form, we solve the equation ax squared plus bx plus c, and that's equal to 0. Okay, where, here's my a value. Well, I plug a into here and here. Here's my b value. I plug here into here. And then my c value is here, and I just plug it in here. Okay, and so if I know what my quadratic is, then I can use the quadratic formula to help me solve that, okay? And so let's look down and let's just kind of look and see what it is, okay? Oh, look, it's the same thing. Okay, now there's a way to remember this, okay? And remember, these are your solutions, okay? This value here is where it crosses the x-axis, okay? So when you evaluate the quadratic formula, these are values for x that show you where the graph crosses the x-axis, okay? But you have to make sure that you set this equal to 0, okay, in order to do that, okay? And there's a way to remember it, and if you know the Pop Goes the Weasel song, then you can remember the quadratic formula, okay? And so if I were to sing it, okay, to remember, okay, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if you know that, you can remember the quadratic formula. It's really not too bad, okay? So let's go ahead and let's take a look, and these are the steps of finding the values a, b, and c. So we want to write the equation in standard form, set it equal to 0, identify what a, b, and c are, okay, and then substitute those values of a, b, and c into the quadratic formula and then simplify it. All right, so let's go ahead and take a look. Let's say that you're given something like this that's not in standard form, okay, and you wanted to get that into standard form. So what you would do for something like that, remember, if you have 2x plus 3 squared, that's 2x plus 3 times 2x plus 3. We multiply that out, we FOIL it, that's going to give me 4x squared plus 6x, and then plus 9. So you get 4x squared plus 12x plus 9, okay? And that would be the standard form, okay? Then you would say, okay, a is equal to 4, b is equal to 12, c is equal to 9, and we'd plug that into the quadratic formula, okay? And so let's write that, okay? If we have a is 4, b is 12, c is equal to 9, all right? And then let's go ahead and solve that, okay? Let's figure that out real quick. So if we solve that, I want you to do that down here. I want to write out the quadratic formula real quick, and that's going to be x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a, okay? So let's just go ahead and we know what these values are, and so let's do that. So I'm going to write x equals, okay, opposite b. So b is 12, so I'm going to do negative 12 plus or minus the square root of b squared. So that's going to be 12 squared minus 4 times the value of a, which is 4, okay, and then times c, which is 9, okay, and then all over 2 times a, which is 4. Okay, so if we evaluate this, all right, let's go ahead and do that. That's going to give me x is equal to opposite 12 plus or minus the square root. 12 squared is going to be 144. And then 4 times 4 times 9, let me get the calculator out. 4 times 4 times 9 is going to give us 144. So I'm going to do minus 144, okay, all over 2 times 4, which is 8, okay? So now, all right, I get x is equal to opposite 12 plus or minus the square root. Okay, 144 to minus 144 is just going to give me 0, which is kind of nice. And then I get 2 times 4, which is 8. Okay, so we get 8. All right, so now that we just get, you know, the square root of 0, that's just going to give me 0. So plus 0 or minus 0, that part just kind of goes away, it doesn't even matter. And so then we get that x is equal to negative 12 over 8. Okay, and that simplifies down to each of these are divisible by 4. And so that's going to give us x is equal to negative 3 halves, okay? So now what I want to do, remember the whole point of this is to find the zeros, to find where this graph crosses the x-axis. So I'm going to do this. I'm going to plug this into my calculator and or into Desmos and see if we hit the graph at just one value of negative 3 halves. Hold on a second. Okay, so what we see here is that if we take this value, this quadratic, and we graph it, we want to look to see where do we hit the x-axis. And we hit it at negative 1.5, which is precisely what we got here. So, you know, that's what we're looking for. So you can always check this graphically. You know, we could have done this, you know, by a number of ways. But, you know, we wanted to show you the quadratic formula and just to show how it works. It does require a bit of computation. You know, make sure you use, you know, your order of operations and all that to help. All right, let's move on. Okay, so on the next page, you know, we have these graphical representations of solution possibilities. So when we use a quadratic formula, we can actually use what's underneath the radical to help us understand what kind of solutions we're going to get. But, you know, we're either going to get two solutions here, okay, where it hits the graph twice. We're going to get one solution where it hits the graph once at the vertex, or we're not going to get a real solution, okay? This would give us a complex solution, okay? And that's where it doesn't hit, all right? So let's go ahead and let's solve this equation here. All right, let's use the quadratic formula. You know, what I notice is that it's not in a standard form, okay? So what I'm going to do is I'm going to move all my values to the left side and set it equal to 0. So what I'm going to do is I'm going to add 6x to both sides, okay? And I'm going to subtract 4, okay? So we get negative 3x squared plus 5x and then minus 4 and set that equal to 0, okay? So this is in standard form, okay? So standard form. So let's apply the quadratic formula, and before I do anything, I'm going to write out that my a value is negative 3, my b value is 5, and my c value is negative 4, okay? So my quadratic formula is x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so when I plug all that in, all right, let's do this. We get x is equal to opposite b, which is negative 5, plus or minus the square root of 5 squared, minus 4 times negative 3, and then times negative 4, okay? And then this is all over 2 times a, which is negative 3, okay? So then, all right, let's simplify this a little bit. And so we get x is equal to, all right, so I've got opposite 5 plus or minus the square root of 25 minus, okay, so now here's what we got. We have 3 negatives that we're multiplying together. So if I have a negative times a negative, that's a positive, but times another negative, that's going to give me a negative. Okay, so if I take 4 times 3, that's going to give me 12. Multiply that by another 4, and that's going to give me 48. So I've got 25 minus 48, and then this is all over negative 6, okay? So now if I take 25 minus 48, okay, that's going to give me negative 23. All right, so I get x is equal to negative 5 plus or minus the square root of negative 23, and this is all over negative 6. Okay, so now the issue is, with this, is now we have a negative underneath our square root. So I'm going to rewrite this as negative 5 plus or minus the square root of negative 1 times the square root of 23, and then that's all over negative 6. So now, you know, when I evaluate this, all right, I get negative 5 plus or minus I times the square root of 23 all over negative 6. Okay, and the issue is that I can't take the square root of 23. That doesn't give me anything real. So I have to keep it like that. If you can't take the square root, then you just can't do it, okay? And I can't simplify that any further, okay? 23 is a prime number. It's divisible by itself and 1, okay? So I can't manipulate that at all. So I have, you just write your answer like this, negative 5 plus or minus I square root of 23 all over negative 6, okay? And there's a couple different variations of this. But, the reality is, guys, I just leave it like that, okay? And that's fine. But the problem is, and the other issue is we can't really graph this on the calculator, okay? It's not going to show us, where you get these solutions from, all right? Graphically. If I graph this, this graph isn't going to cross the x-axis. Okay, it's going to be either, I think, strictly below the x-axis, okay? So that's just something that you kind of have to deal with and do that, okay? So what I know about this is we have to look at what's called the radicand, okay? So we use this thing, and we actually call it the discriminant. So the radicand, okay, slash the discriminant, okay, is what's underneath. This is the what's under the radical sign, okay? And so what we know is that, if the number is positive, okay, if this number is positive, okay, there are two real solutions if the radicand is positive, okay? We get one real solution if the radicand is 0, okay? And then we have no real solutions. We get complex solutions if we have a radicand that is, negative, okay? And that's the idea, okay? Okay, and that's what the discriminant is, okay? It's that value of b squared minus 4ac. So what we can do is we'd want to describe the zeros of this function. So if it's positive, you have two real solutions. If it's 0, you have one real solution. If it's negative, okay, I don't know what is going on there. B squared minus 4ac, if that is less than 0, then you get 0 real solutions, okay? So let's take a look up here. Let's describe the zeros of this function. And so what I want to do is I'm going to just get y equals. So I want to get y equals ax squared plus bx plus c. All right, and so what I'd want to do is I'd want to subtract 7x first from both sides, and then I'm going to add 1 to both sides. And so we end up getting y is equal to 9x squared. 3x minus 7x is going to give me negative 4x, and then plus 6, okay? And we just want to determine, we don't want to know what the zeros of that function are. We just want to know, what kind of solutions we're going to have. So I'm going to do this. I'm going to find out what b squared minus 4ac is. So if I do b squared, means I'm going to do negative 4. Okay, so hold on. Here we've got a is equal to 9, b is equal to negative 4, and c is equal to 6. So if I do negative 4 and square it, minus 4 times 9 times 6, okay, this is going to give me 16 minus, okay, 4 times 9 is 32, or I'm sorry, 36, 4 times 9, and then times 6 again is going to give us 216, okay? So if I take 16 minus 216, that's going to give me negative 200. Because this number is negative, all right, then we have no real solutions, okay? We have no real solutions. We just have, we have complex solutions, all right? So you can tell by how many, what the value is of your discriminant tells you what kind of solutions you're going to have, okay? So down here, let's use the same, the nature of solutions here. Use the discriminant to answer the question. So let's take this equation here, and let's do 32x minus 4 is equal to 4x squared plus 60. Okay, let's subtract 32x from both sides, so minus 32x, and then let's add 4, So we get 0 is equal to 4x squared minus 32x, and then plus 64, okay? So let's do b squared. First of all, let's say a is equal to 4, okay, b is equal to negative 32, and then c is equal to 64. So let's do this. Let's say, let's do b squared minus 4ac. And so if we do negative 32 quantity squared minus 4 times 64. Okay, let's see what happens here. And so let me do 32 squared. That's going to give me 1,024. So 1,024 minus 16 times 64 gives me 1,024. So when I take this, I end up getting a value of 0, okay, which means I have one real solution, okay? And so that's what I get over here. So I get one real rational solution, okay? And you could do, so then the question says, you know, over here, it says how many x-intercepts do you have? Well, that's the same thing as you're doing over here, just finding how many solutions you have, okay? They mean the same thing. So let's do this. Let me just go ahead and add 5 to both sides here. Add 5. So I'm going to get y is equal to 0.5x squared plus 6x, and then plus 2. So my a value is 0.5. My b value is equal to 6, and then my c value is 2. So if we do the discriminant, we say, okay, let's do b squared minus 4ac. Then, you know, we want to do 6 squared, okay, minus 4 times 0.5, okay, and then times 2. All right, so what this is going to give me is, okay, this is going to give me 36 minus, okay, if I do 4 times a half, 4 times 0.5 and then times 2, that's just going to give me a value of 4. So I have 36 minus 4, which is going to give me 32. Okay, this number is positive. So what this means is that because that's positive, I'm going to have 2 x-intercepts. Okay, and that's it. So, you know, guys, I hope you enjoyed this video. I really enjoy using the quadratic formula. I think it's pretty fun. But, you know, just make sure you can identify A, B, and C, plug it into the formula, and go from there. All right, see ya. Bye!